Hey guys, so here's the rest of 6.1, and we're still talking about radians, but we're also going to be talking about arc length and area of a sector, which are reviewed from geometry. The main reason I'm really mentioning these two things is because I know it's something that the SAT likes to ask about, and they're actually really easy problems to do. So here are the formulas that you need. Now the SAT, I believe it gives you the formulas for circumference and area of a circle, but I don't think it gives you arc length and area of a sector. But it actually is really simple. So if I'm doing the arc length, part of the circumference is what I'm finding. So the circumference formula is pi times diameter. And because I'm only finding part of the circumference, I need to say how much I want to find. So in this problem, I would do pi times 10, because the radius is 5 and the diameter is 10, and the degrees that I want is 80 out of 360. So if you know circumference, then you just have to say how much you want. I want 80 out of 360. If you are wanting to find this part of the circumference, you would have to do 360 minus 80, and then that would be your degrees. Area of a sector formula is very similar. You're still doing degrees out of 360, but you're using the area formula. So area is pi r squared. And then I just say how many degrees I want out of 360. So those are the formulas. I'm not going to spend too much time on that. What I do want to talk about is how radians relates to area of a sector and arc length. Because now you know what a radian is. You know that a radian is the radius wrapped around the circle. And so a radian is an angle that is formed by doing that process. So these are all the same length when this is a radian. And so then we can start to look at problems like, what if this is 2 radians, or what if it's a half of a radian, and what would that relationship be? So these problems are actually pretty simple to do if you can multiply and divide. And I know we can do that. So we've got looking for how many radians this is, what the angle is. And now you would have done this in geometry, but you would have gone through a really long process to figure out what that angle is, and I'm just going to show you a much easier way to find that. So keep in mind that a radian is approximately 50.73 degrees, which is 180 over pi. And keep in mind what a radian is. So taking the radius and wrapping it around the circle. Well, if the radius in this first one is 3, and I were to wrap 3 and then close it, that would be 1 radian. But because I'm taking 3 and putting it on there twice, the angle has to be 2 radians. Okay, so we're saying how many times is the radius taken around the circle to form that angle? 2 times. Okay, so if you look at the second one, we've got 5 and 5. And obviously this would be 5 as well. So that is exactly 1 radian. Now, what if our radius is 6 and we're only wrapping half of that around the circle? Well, then we have half of a radian. So you can see those are pretty simple. Okay, kind of working in a different direction. Now I'm giving you the radius, and I'm telling you what the angle is, and I want to know how much this is. So if you look at number 4, we've got that the radius is 2. And if your radian is only 1/4, that means this part, and I know these aren't drawn to scale, this part, the concept is it's going to be 1/4 of this. So 2 divided by 4 is a half. So that is what x would be. So if I took the radius, 1/4 of it, and wrapped it around the circle. Okay, so number 5, now I have a half a radian, and this is 6. So if my radius is 6 and I only wrap half of the radius around the circle, that would be 3. Now 1 radian is pretty simple because it's just going to be the same thing. And the last one that I have is half radian, but this time I know the arc. So what we're saying is that this is half of what the radius is. So that would be 12. So if my radius is 12 and I took half of it, I get half a radian. Alright, so let's talk about area of a sector. So that's the pi r squared formula times the degrees out of 360. What you need to know is that a radian is 57.3 degrees, or you can use the 180 over pi. I'm just going to use 57.3 because I think that'll make it a lot easier going with the same formula that we had before. So the formula is pi r squared, and my r is 6, so that'd be 36. I'm going to take that and multiply it by the radian. So I need to do a little conversion here first, okay? So if I take 0.5 and times it by 180 and divide by pi, I get 28.6, or you could just take 57.3 and divide by 2. You're going to get about the same thing. So approximately 28.6, or even if you had 28.7, it just depends on how you're doing it. It's not going to make that big of a difference, over 360. And you could even get really specific and do 180 over pi, and I can show you that later, but this is just going to be the easiest way, going with that same formula. So if we're in radians and our formula uses degrees, then you want to be in degrees. And you could adjust this formula to be in radians because you know that 360 in radians is 2 pi, so that would be the other option. And I'm just going to type this all in the calculator. So pi times 36, in parentheses 28.6 divided by 360, and I get approximately 8.98, or if you just want to round up to 9, that's fine. Whatever your units are, squared, or square units. Okay, last one for area. If I have a radius of 8, so that's 8 squared, 1 radian is 57.3 degrees divided by 360. And just type it all in the calculator. So, like I said, really, I know that a lot of you are preparing for the SAT. That's something that you're stressing about. Those are formulas that are helpful to know, but it does relate to what we were talking about with radians. So I wanted to show you that. If you would like to practice some problems on radians at this time with the area of a sector and arc length, these are the problems that relate to that. If you haven't done the other ones yet, make sure you do those all at once. You can hand them into me when I see you next time. And if you have questions, please shoot me a text and remind me. And also, I will be staying after Tuesday if you need help. So, good luck.